Okay, in this video we're going to work through the activity on page 4 of your booklet. So if you could get this page up, classifying models. And you'll notice on the right hand side of the screen I've got the 8 models we already used last lesson when you were grouping. And now that you've done the Kahoot, it's time for you to go back to those models and double check that you really understand when something is an element or compound and when something is atom, molecule, or giant. Now, I'm going to tell you right now, none of the substances A through H are mixtures, so you can ignore that word mixture. I haven't given you any of those. Right, so the task is this. You need to draw a picture of the model, and then you need to classify it. So I'm going to do 2 as an example for you. Then I'd like you to pause the video and try the rest, and then unpause, and I'll go through the rest of the answers. So let's start with A. A is 2 red atoms they're actually connected with 2 bonds. That's called a double bond. Every other bond in this activity is a single bond. We're going to learn about that in a future topic, but it's still good to draw an accurate diagram. And there's the second one. These are both red. They're the same type of atom, so this is an element. They're not single atoms. They're going around in pairs. So this is a molecule. And that's it. That's all I have to do for A. Let's skip to D, because D is a really hard one to draw. Don't stress about D or H. I can tell those structures are complicated, right? So just do your best. I've been drawing these a long time. So there's a black atom at the top, and it has 4 coming out of it. Again, don't worry about yours looking like mine. Just make sure it's clear that you've got a really complicated web of atoms, all interconnected. And the black color is carbon. That's actually diamond. The reason diamonds sparkle and shine here and give out all that light is because of that pyramid structure. It goes on until you make an entire crystal. So this is all carbon, so this one's also an element. And it's not a simple molecule, it's definitely one extended giant structure. Alright, so just like that, a drawing and 2 circles. Pause the video now. I'm going to make this picture nice and big for you. And have a go at the rest. Okay, so hopefully you paused and went through these. So now I will show you how I would draw them. So substance B had a green atom and a white atom bonded to each other. So I'm just going to color one in. If you had colored pencils or something, that's even better. This is clearly a compound because it has 2 different atoms bonded together, and they're molecules. I love A and B next to each other. It's a really nice way of showing both of these are molecules, but one is an element and one is a compound. All right, substance C was the one with the beige atoms all by themselves. So this is the only one on the whole page that are atoms, and they're all the same color, the same element. E were the 2 green ones single bonded to each other, and there were 3 units. Like that. So these are all the same element, and they're in tiny groups, so molecule. Substance F had a blue atom in the middle, and 3 white ones around it. Blue is nitrogen, and the white are hydrogen, which makes this a very interesting substance. NH3 is the formula. Just a little bonus fact for you. That's called ammonia. Ammonia has a really interesting history. Its industrial production was designed by a guy called Fritz Haber back in the early 1900s. And he enabled the production of ammonia, which was used to make fertilizer, and that's the only reason we have agriculture on the scale we do. If it wasn't for this little molecule, the billions of people on Earth right now would not have food. There simply cannot generate a high enough yield of crops without ammonia-based fertilizer, because they need the nitrogen. So in a way, Fritz Haber was the savior of humanity, billions of people. On the flip side, this same little molecule is used to make dangerous chemical weapons and explosives. And in fact, a lot of his work was used against his people in Germany. He was a German Jew right before World War II and was used to kill hundreds of thousands of people. So it has a very storied history, very interesting molecule, NH3. So yeah, it is indeed a molecule because you can see it's a small group of atoms and it's a compound. We have nitrogen, the blue one, and hydrogen. Substance G. Yours might look a little bit tricky if you try to do it 3D. I'm just going to do it in 2D. Green, yellow, green, yellow, yellow, green, yellow, green. Nice, neat rows alternating. It's a compound because there's green chlorines and yellow sodiums. And it's giant because they're all connected in one big network. H is interesting because it's similar to D. It's all carbon, but it's a different type of carbon. It's actually graphite. And graphite is when the carbon atoms form these hexagon layers. Yours might not look like this if you tried to draw it 3D. Don't stress. As long as you showed them all in one big chunk, I'm happy with that. So it's clearly giant, and it's an element just like diamond was. Graphite's actually this pencil lead. It's in these nice sheets, means it can slide off onto the page. And there you have it, classifying models.